Okay, so today we're going to continue our work on one variable statistics by looking at measures of central tendency. So basically what we want to be able to do by the end of this lesson is we want to determine the mean, the median, and the mode if we are given either raw data or we are given data that has already been grouped together into a frequency distribution table. We want to be able to sort of assess when each of these three measures of central tendency is the most appropriate measure for the data that we're working with. And then at the end, we'll take a look at how you determine what's called a weighted mean for a set of data. So what do we mean by central tendency? Basically, if you've got some data set, like let's say this set of the times to assemble our tricycle that we've been looking at over the past couple of lessons. The measure of central tendency for a data set is the value around which most of the data is grouped, i.e. it's like the middle of the data set. It's in the center. Okay, it is, or you can think of it as sort of the most representative value of the group. So if we're looking just at this histogram that we have here, we might say that the middle was, I don't know, somewhere around here, around 20. Okay, now we would like to know it a little bit more accurately than just by looking at the graph and saying, oh, that's the middle of the graph, because it could be that it's over here a little bit more because you can see that peak is a little bit higher. It could be that it's over here a little bit more. So we want to have a way of mathematically determining this measure of central tendency here. So usually what we use is the mean, the median, or the mode. And I think these are all familiar to you from previous math courses. So we'll just give a quick overview of them right here, and then we'll get into an example. So the mean is basically the average of the data. Okay? It is the total of all of the data points. So you add them all up and you divide by the number of numbers, or the number of data points. Statistically, we'll often use the symbol X bar to refer to the mean. And the formula for this that appears on your formula sheet looks like this. Okay. So this big fancy, this Greek letter S here, of course, means the sum. All of the xi's represent individual points. So the numerator just means add up all of the points, and then of course n is just the number of points. So again, just add them all up and then divide by the number of points. The median is often referred to as the middle value. Now, it's the middle value when they are written in order. So the first step to finding the median is, of course, to take your data points and write them in order from smallest to largest. And the mode is the value that occurs most often. Okay, now, how do we know which of these things we want to use? Well, which one we use depends on the data that we have. And the thing that we're looking for in the data is what are known as outliers. So an outlier is just a piece of data that deviates from the rest of the data, or the trend in the rest of the data. Deviates or differs or the trend in the data. Okay, so I've got two graphs here. On the left here, I've got a scatter plot. The outlier in this one is this point right here. It does not follow the trend of the rest of the data. Okay, now Notice it's not the value of that data point. Like that data point is about 6,000. Okay, it's not that 6,000 is a number that is completely out of line for this data set, because over here we have other numbers that have a value of about 6,000 as well. It's the fact that this value of 6,000 occurs at an x value of about 30, when based on the trend we expect it at an x value of about 80. So you can't always tell just by looking at the numbers what an outlier is. Sometimes you have to look at the trend that's in the data. And we'll be talking more about trends and things like that when we get to unit 3.4. In the second graph over here, we have got what we could call a histogram that we've been looking at these. And in this one, the outlier might be whatever this number is way down here. All the rest of the data seems clustered right around 0. Okay, but we've got this one point that's way down here at like -6 or something. So this looks like an outlier, and it kind of skews our graph a little bit. Okay, so we might say that this graph is skewed to the left because of that outlier. What does this have to do with measures of central tendency? Well, if our data set is symmetric, the mean and the median are about the same, so we can use either one. So if we talk about this in terms of the distributions we've been looking at, if our data set follows the normal distribution, which is symmetric, then we can use either the mean or the median. Also, if we have uniform distribution, the mean and the median are about the same, so we can use either one. Where we have to be careful is if we have a data set that has outliers in it, because outliers have a very, very large effect on the mean that you calculate. They have a lot less of an effect on the median. So if our data set has a lot of outliers or it's skewed in some way, we're going to use the median rather than the mean because it is less affected let's say by outliers than the mean is. What about the mode? Well, you only really use the mode when you have nothing else available to you. It's sort of the least reliable of these three measures of central tendency. Okay, so usually if you've got qualitative data, like you asked everybody what their favorite color is or something like that, then you would have to use the mode to describe it. Remember, qualitative data is words, not numerical, or not quantitative. Okay. So if you have qualitative data, you can't calculate the mean and you can't calculate the median. So the mode is all you have. So the mode is what you would use. Okay. So looking at this data set that we've been talking about for the past few lessons here, the time to assemble our tricycle, we could ask a question like, well, how long does it typically take people to assemble this tricycle? And we could take our raw data, we could calculate our mean, our median, and our mode, and we would find that the mean is 20, the median is 20, the mode is 20, which makes sense for this nice symmetric distribution that we have. So either one of these would be good, so we would use either the mean or the median to talk about our value of central tendency, which is sort of right where we expected it to be, right at this value of 20 here. Okay. So let's do an example here. So here we have a set of data. We want to determine the mean, median, and mode for this set of, these apparently represent marks on a test. And we want to ask ourselves which one is the best measure of central tendency. So if I saw a question like this, the first thing I would do is, I know I'm doing the mean, the median, and the mode. First, I'm going to figure out how many data points I have. I'm just kind of going to count them up here. 2, 4, 6, 8, 10, 12, 14, 16. I've got 18 data points. Okay. And the next thing I'm going to do is I'm going to take these data points and I'm going to write them in order. So I'm going to find the smallest one, which is 12. I'm going to write it first. And then I'm going to go, next smallest is 15. And then I'm going to find the next smallest one, which is, what is the next smallest one? I think it's the 44 here, and so on and so on. Okay, just crossing them off the list and rewriting them. Okay, so if I do that, what I'll end up with is a list that looks like this. Okay, and after I've made this list, I'm going to count the number of numbers again just to make sure I got all of them in my list. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so I still have 18. Perfect. Okay, once these numbers are written in order, let's start with the median. Having them in order just makes all of these easier to calculate. So our median is the middle value when this is written in order. So if we've got 18, the middle value, the middle of a list of 18 numbers is the ninth one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 numbers over here, and there are 9 numbers over here. So this right here is the middle of our data set. So our median is going to be halfway in between those two numbers that sit on either side of that middle point. So I'm going to take that 69, that 73, and I'm going to average them together to get 71. Okay. So that is our value for the median. For our mean, or X bar, as we write it in statistics, well, I've just got to add up all of these 18 numbers. So I'll just start punching them into our calculator, sum of all the X, and then I know I'm going to divide it by how many numbers that I have. So putting all the numbers in my calculator, I get 1158. There are 18 numbers there. Gives me a mean value of 64.3. For the mode, once these are written in order, it becomes pretty easy to see how often each number occurs in my list. So I'm looking for numbers here that occur more than once. So let's see. We've got 61 and 61. Are there any other numbers that occur more than once in this list? We got an 80 here, and oh, that's weird. I didn't put this 80 in the right order here. Okay, that's weird. Okay. That's bad, but it's not going to affect my median, so it doesn't change my median, and it certainly doesn't change my mean. So I think I'm okay there. So this data set actually has two modes, 61 and 80. Okay. Now, which one is the best to use as our value central tendency? Well, probably not the mode, because we actually have access to the mean and the median. Are there any outliers in this data set? There are, in fact, two outliers. These two numbers right here. Okay? 12 and 15, those are much smaller than any of the other numbers. Like all the other numbers are from 40 up to 80, or 40 up to 90, okay? And then 12 and 15 are way, way, way down at the bottom. So the effect of those two outliers is going to be to make the mean value that we calculate smaller than what the actual center or middle of the data set should be. So we are going to use the median in this case. Median is best due to outliers. And you can just use just from comparing those numbers that the mean has been made smaller than sort of the middle of the data set, that value of 71, because of those outliers. Okay, so just to make one last point here, remember this is 1D data that we're working on. The whole unit is called 1D statistics. We've got just this list of numbers here that represent test scores, so we are still dealing with one-dimensional data here. What happens though if somebody has taken that one-dimensional data and they've already done a little bit of analysis on it? So by doing something like grouping it together in a frequency distribution table. Okay, so here's the situation. A group of children were asked how many hours a day they spend in front of a screen, TV, computer, phone, whatever screen you want. The table at right summarizes their responses. So we've got the number of hours, 0, 1, 2, 3, 4, 5, the number of children who said that they spend that number of hours in front of a screen. And so this is still 1D data because the data that we still have is the number of hours each child said. So just a list of number of hours. It looks like two-dimensional because we've taken it and we've grouped it together, but it's still just 1D data. What do we want to do? We want to determine the mean, the median, and the mode. Okay. Well, the mode is pretty easy. So let's start with it. The mode is just going to be the number that the children said most frequently. So just looking at these, 7 children said they spend 2 hours. That's the largest in that table of the number of children. So that's going to be our mode. How can we calculate our mean? Well, the mean value is the total number of hours divided by the number of children. We can find both of those things from the table that we have. Okay? So we've got this column here for the number of children. We can just add up and find out how many children we have. 1 and 4 is 5, 12, 12 and 6 is, we have 18 children. So we just need the number of hours, total hours from all of the children, and then we're going to divide that by 18. Now we can get the total hours just by multiplying the numbers in the first and the second column. Okay. One child said that they spent 0 hours. How many total hours does that represent? 0. 4 children said that they watched 1 hour. So that's 4 total hours. So we can imagine that as if we were listing out all of the data one after each other, we would have 4 ones right after each other. And then after those 4 ones, we would have 7 twos because 7 children said that they watched for 2 hours each night. But that's going to give us a total of 14 hours. Then our 3 threes, which give us a total of 9 hours, 2 fours, which give us a total of 8, and then 5 hours from this last person who watched 5 hours. We can just add up the total number of hours, 18, 27, 40. So our mean value is going to be 40 divided by 18, or 2.2. What about the median? Well, the median would be the middle value if we were to take all of these numbers and write them out one after each other. Okay. So to help us figure out the median, what we're going to do is we're going to fill in this last column that we've made over here called the cumulative number of children. And we're just going to take the number of children in each row and keep adding it up to get a sort of a running total. So in the first row, we have 1 child. By the time we get to the second row, we've got that 1 child from the first row plus the 4 from the next row for a total of 5. Then we add on the 7 from the next row to have 12. Then add on the 3 from the next row to have 15. Then the next 2 give us 17. And the last one give us 18 children by the time we get to the last row. which agrees with our total number of children. If we have 18 children, the median is going to be halfway in that data set, is going to be halfway between the 9th and the 10th value. Okay, so we would find the 9th value and the 10th value, and we would average them together. So this cumulative number of children helps us figure out where that number 9 and 10 come from. So if we start at the top row here, we've got 1, then by the time we get here, we're up to the 5th number. But by the time we get to the end of this 3rd row here, we're up to the 12th number. So the 9th and the 10th are both in this row right here. Okay. So what this means is if we were to write all of these out in order, one after the other, the 9th value and the 10th value would both be a 2. So our median is going to be 2 as well. So in this case, our mean, our median, and our mode are pretty similar to each other. Our mode is 2, our median is 2, and our mean is 2.2, suggesting that this is a symmetric distribution. Okay. All right. One last thing here. Okay. So we don't often, well, we often use means, but one thing we use a fair bit is what is called a weighted mean. So in a weighted mean, the numbers do not contribute equally to the mean. Some numbers are weighted so that they contribute more than others. Now this is the formula for a weighted mean, and this is right off the formula sheet. Okay, so again, x bar here is our mean. X's are our individual data points, our individual values. And W here and here are the weights that we assign to each of these values. Okay. So basically this formula is you take each value, multiply it by its weight, and then you divide by the sum of all of the weights. So it's like the sum of each value times weight divided by the sum of the weights. So, and of course, if all of the weights are exactly the same, then this weighted mean is exactly the same as the normal mean. You can imagine just putting in a 1 for each one of the weights. Okay. So here is sort of the most common example where you're going to run into a weighted mean. Somebody is calculating their grade for this particular course. Okay. The table below summarizes a student's grades on 4 assignments and 1 test. Find their overall mark for the strand. So on the first activity, they got a 90%. It's assigned a weight of 10. The second one, they got an 85, it's assigned a weight of 15, and so on and so on and so on. And you can see the test at the end has the largest weight. It's weighted at 50. Now all of these weights here add up to 100. Okay, so each weight is kind of the percentage of that strand mark that each activity represents. Okay, now they don't have to add up to 100, they just do in this case. So how are we going to, so these grades here are our values, and these weights, of course, are our weights. So let's figure out the weighted mean here. It's going to be the sum of all. We're going to take each value, multiply it by its weight, and then divide by the sum of all of those weights. So we're going to have in the numerator 90 times 10 plus 85 times 15 plus 92 times 10 plus 83 times 15 plus 75 times 50. All of this gets divided by, and let's add up those weights. So we'll add up 10 plus 15 plus 10 plus 15 plus 50. We know that those weights add up to 100. A little bit of calculator work, and the numerator is 8,090. So our weighted average here would be about 80.9. So final mark for this strand for this student would be about 80.9 or 81. Now, this leads to kind of, well, a lot of students will come to me as a teacher and they'll say, well, why did I only get an 81 on this? I mean, I had most of my marks were above 85. And sure enough, a 90, an 85, and a 92. Yep, most of those marks are in fact over 85. But the mark that contributes most, or that has the highest weight, is this test here, which unfortunately is this person's lowest mark. So it is, you have to take into account how the marks are weighted in order to figure out what the appropriate measure for the overall mark is going to be.